Hello friends, so in today's question, a block of mass m rests on the top of a block of mass 2m which is kept on the table. The coefficient of kinetic friction between all the surface is mu, which is equal to 1. A massless string is connected to each mass and wraps halfway around a massless pulley as in the figure. Assume that you pull the pulley with a force of 6 mg. What is the acceleration of your hand? This is the figure in which the mass m sits on the top of 2m. M and 2m are connected with the help of pulley, and this pulley is being pulled by a force of 6 mg, and the coefficient of friction between each surface is given as 1. So first of all, let us draw the free body diagram for here the mass m as well as 2m, and then we are going to move forward. Okay. So let us draw it for m. Okay. So this is our mass m and this is our mass 2m, and we assume that retention T here, and obviously this will be T, and this will be giving us a 2T. Okay. Therefore, for the mass small m, there will be tension T toward this direction, and there will be also tension T for the mass 2m. Okay, and this is our base. Mass 2m is everything will be moving towards right side, so there will be a frictional force. Let us call this as F2, FR2. Okay, and this 2m will try to move. Okay. Now there will be frictional force between m and 2m. Okay. So what we do, this force the mass m will try to move 2m towards, you can say, right side, and let us call that friction as FR1, and equal and opposite will be acting on the above block, and let us call that FR1, sorry. Okay, we can also analyze this thing in a different way. We can say that let there is no friction between m and 2m. Okay, we say let no friction between m and 2m. Okay. So we find out the acceleration of m independently. Okay. So we can say that acceleration of m will be equal to the force, which is equal to tension T, and divided by m, and acceleration of 2m will be given as T minus FR2 divided by 2m. So we have T minus FR2 divided by 2m. So from here we can more or less, this is FR2, we can say that acceleration of acceleration of m will be larger than acceleration of 2m. We can get more or less idea. Okay. So in that case, if the acceleration of m is higher as compared to 2m, so we can say from here that acceleration of m is greater than acceleration of 2m. Or in a word, we can say that am is greater than 2m. So if acceleration of m is greater than 2m, then this m will try to force 2m towards the right with the friction force Fr1. So you can say therefore mass m block will try to move block of mass 2m towards right. Thus, we can say that this mass m will apply a frictional force which we assumed as Fr1 towards right, and equal and opposite will be acting on Fr1. So we can say here from therefore block mass m will try to move block mass 2m towards right. With the frictional force which we assumed as Fr1. So usually this helps in defining the direction of the frictional force. If the acceleration of mass 2m will be higher, then this 2m will try to force mass m towards right. So this will be now Fr1 here will be coming, and equal and opposite there will be Fr1 at 2m. So this is the best approach, that we assume there is no friction between the two bodies. Okay, remember this is no friction between m and 2m, not between the 2m and the ground. So we find out their respective accelerations, make a comparison. Based on comparison, we can decide that which of the block is having the higher acceleration, and accordingly we can decide or find out how the frictional forces will be acting on each other. So we can clearly see that this m will be applying a frictional force Fr1 towards right, and equal and opposite will be acting Fr1 on the block m. Okay. So let me draw the free body diagram here again, because some of the things are missing there. So we have this m, and we have tension T. This will be our Fr1, and we have 2m, tension T, and this will be Fr1, and we are going to have here Fr2. Okay. Next, there will be a force acting in downward direction, that is mg, and here there will be a normal n1 whose value will be equal to mg. Okay. And here, as mass m is above 2m, so total here will be coming as m plus 2m to g, which will be nothing but 3mg, and here there will be normal n2, and whose value will be equal to 3mg. And last is about the pulley. So we can draw the pulley also. So it is going to have a tension T. Okay, this will be T tension and T tension, and there is a force F. Okay, so we can clearly see from here that F is equal to 2T. From here we can say that F is equal to 2t. Okay. Let me write it here actually. For pulley, we have F is equal to 2t. Or from here we can say T is equal to F by 2, and F is given as 6 mg. From here we can say that T is equal to 6 mg divided by 2, or we can say T is equal to 3 mg. We found out the value of the tension, and next we assume that both the blocks are traveling with the same acceleration. Assuming both blocks are moving with same acceleration. Okay, and let us suppose that is given as capital A. So we have this will be m plus 2m. Okay, and there will be FR2. Okay, and we can say there is acceleration A towards right side, so we can say that 3m into A. Okay, or we can say over this is tension T. Okay, or there are two forces, T as well as T, so we have 2T. So from here we can say 2T minus FR2 is equal to 3 mg into A. And we can find out our FR2. Okay, so this is our FR2. FR2 will be equal to, let me find it here, you can say our FR2 is equal to mu into 3 mg. Okay, so we have mu into 3 mg, mu is 1, so this will equal to 3 mg. We substitute the value. We already know value of T, that is 3 mg, so this will be 6 mg minus 3 mg is equal to 3 mg multiplied by A. And we can find out our acceleration. So acceleration will be equal to, we have here, sorry, this is mass, not G. So we have 3 mg divided by 3m, so we get acceleration, that a common acceleration is coming as G. So this will be our maximum acceleration with which the both blocks can travel. Okay, or we can say block of mass m as well as 2m separately also going to travel with this acceleration. Here we can say that the maximum acceleration with which the blocks can move is equal to A. Let me write it A max as well, which is equal to G. So this is a maximum acceleration, and let us find out whether this, for this acceleration, what will be the value of the F1. Okay, let me draw the block diagram for free body diagram for M. So we have this FR1 and we have this tension T, and in this direction it is moving with the acceleration of G. So we can write the equation that T minus FR1 is equal to mg. We already know value of T, that is 3 mg. So we have 3 mg minus FR1 is equal to mg. Okay, you can see that FR1 will be equal to 2 mg. But the maximum value of FR1 max, okay, so we can see that the maximum value of FR1, which will be FR1 max, will be equal to, so we have mg and this is a normal n1, so this will be mu n1, or because the mu is 1, n1 is mg. So from here we can say that our FR1 max is nothing but equal to mg. So we will make a comparison between the maximum available and required value of the friction. Okay, this is the required value and this is the maximum value. Sorry. So this is our maximum value of the friction that is available, and this is the required value. We can clearly see that maximum value of the friction is less than the required value. Okay. So from here we can say that maximum value of friction, that is FR1 max, is less than the required value, that is FR1. Or we can also write it simply like this, that is FR1 max is less than FR1. So based on this, we can say that there will be slipping between the mass m1 and 2m. Sorry, not m1 but m and 2m. So let me write it again here, that is FR1 max is less than the FR1. So from here we can say that there will be slipping between m and 2m. And based on this, we can clearly see that the actual value of FR1, therefore the actual value of FR1 will be equal to, that is FR1 max. You can say that our FR1 will be equal to, FR max was equal to, FR1 max was mg. So we can say FR1 will be equal to nothing but mg. Okay, now it's very sure that both the blocks will be moving with different acceleration. Okay. We can also say this implies that both blocks m and 2m will be moving with different accelerations. Different accelerations, and let it be, let for mass m is A1 and for mass 2m let it be A2. So now we draw the free body diagram for M1. So we have M, we have tension T, and there is FR1. Now it is moving with the acceleration of A1. So from here we can write that T minus, so we can say for block M, we can write T minus FR1 is equal to M into A1. And we can say A1 will be equal to T minus FR1 divided by M. Value of T is equal to 3 mg and FR1 is mg divided by M. So we have this equal to 2 mg divided by M. M and M cancels out. So we have acceleration of mass M is equal to 2g. And now let us draw the free body diagram for 2m. So this is about 2m. So this is tension T, FR1, we have FR2, and acceleration is given as A2. We can say for block 2m, we get the equation as T plus FR1 minus FR2 is equal to 2m multiplied A2. From here we can say that our A2 will be equal to T plus FR1 minus FR2 divided by 2m. T is our 3 mg and FR1 is our mg and FR2 is our 3 mg, I think. Yeah, FR2 is 3 mg divided by 2m. So 3 mg and 3 mg cancels out. M and M goes. From here we can say A2 is equal to g by 2. So we found out the acceleration of both the blocks. Next is we are going to find out what will be the acceleration of the pulley. Now this is the pulley and we have here two blocks. Acceleration is A1, this is A2, and let us acceleration of pulley is AP. So this AP will be the average of A1 and A2. You can write here acceleration of pulley, that is AP. A1 is also in this direction, A2 is also in this direction, so we have AP. So it is A1 plus A2 divided by 2. We substitute the value. A1 is about 2g and this is g by 2 divided by 2. So we get our AP as 5 by 4 multiplied by g. So this is nothing but the acceleration of the hand, because hand is pulling the pulley. So you can say this is the acceleration of the hand. This completes the question. Okay. Thank you.